Hello students, myself Dr. Rupali Vigoyal working as Assistant Professor in Civil Engineering Department at SVIT Vasar. Today I am going to discuss about two important topics which are included in the syllabus of subject Water and Wastewater Engineering for Civil Engineering 6th semester. These two topics are water treatment as well as wastewater treatment. These two topics are very important as far as exam point of view because in many examination paper you may find its line flow diagram and its working functions of each and every unit that is to be written in examination. So let's discuss this both water treatment as well as wastewater treatment. So when we are talking about water and wastewater treatment, you have to first understand the water supply scheme as well as sewerage system, because if you don't know about these two schemes, then you won't be able to understand its treatment. So first we are starting with this particular water supply scheme. So for the water supply scheme, first we have to decide the source of water. So any source of water that you have to select, it depends upon your town or city nearby, that which source of water is available. It may be a surface water source or it may be a groundwater source. So generally for the surface water source, you have to provide the structure, that is for the collection structure, and that is called as the intake structure. So intake structure is also one of the topic that is included in your particular syllabus. Once we are collecting your water from the surface water source, it has to be conveyed to treatment plant, that is water treatment plant. So this conveyance, it is nothing but it is consisting of pipeline. Once it has reached to treatment plant, different treatment methods are to be applied so that this water, it fulfill the requirement of IS 10500/2012, and that water is to be distributed then. So after complete treatment in water treatment plant, water is supplied through water distribution system. So this is also one of the topic that is included in detail in your 6th semester. Once it has reached to your house water, then it may be resulted in wastewater, because we are using this for many purpose. And once it has become wastewater, it will be transferred to your sewer pipeline. So the whole system, it is called as the sewerage system, that is the collection and transportation of water, and that will transfer water to wastewater treatment plant. So in wastewater treatment plant, complete treatment is given to this wastewater, and then after there are various options for that. If you are giving the conventional treatment, then after this wastewater treatment, the resulting effluent that may be disposed of in nearby river or stream, or if you are going for some additional advanced treatment methods, then also you can utilize that treated wastewater for reuse and recycling purpose also. Before understanding the flow diagram of water treatment plant, we have to understand objectives of water treatment plant. Why we have to treat our water? So first thing is that as we are going to supply it and we are going to drink that water, the quality of water after treatment, it should fulfill the drinking water standard requirement, that is 10500/2012. So whatever water which is treated in your treatment plant, it should be safe and it should be pleasant to taste. It should not have any impurities. It should be able to remove all the dissolved gases, murkiness and color from the water, to remove the unpleasant and objectionable taste and odors and hardness from the water. Now this is the basic requirement to kill all the pathogens. Pathogens are those microorganisms which are very harmful and result in waterborne disease. So this is the very important treatment that has to be provided. If you are not providing other treatment due to some reason or due to some emergency condition, at least you have to provide the treatment to kill the pathogens, and that is generally done with the help of chlorination or disinfection, also to make it fit for the domestic and industrial purpose. The quality of the water which is treated in your treatment plant, it should be that way that it to eliminate the tuberculating and corrosive property of water which affects our water supply. This figure shows the tuberculation and corrosion. Now basically this tuberculation, it is nothing but it is the deposition of ferrous oxide, or which is called as the tubercle, from the water due to some bacterial action. And while as we are talking when we are talking about corrosion, it is related to rusting action, in which the material is taken away. So generally if this corrosion or tuberculation takes place in certain water supply pipelines, then it affects the carrying capacity of your particular pipeline. So this tuberculation and corrosion uh, uh, is to be properly taken care when we are supplying water for the distribution system, and it should not form this tubercle or it should not be corrode. Now, if you want to draw flow diagram of any conventional water treatment plant, then you have to understand first steps. So first step in any conventional water treatment plant is the intake structure. So this intake structure is nothing but it is useful for the collection of water and to supply that water to water treatment plant. So basically this is used for the surface water source. So whatever the well or collection structure which is constructed in water sources such as river, lake, canal or reservoir, it has to convey it to the water treatment plant. So basically the function of intake structure is to collect water from the surface water source and transfer it to water treatment plant. The next is screening. Generally this surface water source, it may be having some large floating impurities that may be possible. So before applying it to any water treatment plant, it has to be removed with the help of the screens. So screens are nothing but they are some bars which are provided at certain spacing, so that it will not allow the large floating impurities such as some tree trunk or some other floating impurities to pass through that, and it keeps all the natural contaminants away from it. Now next process is aerators. Now this is basically optional. If in your river water or surface water source it is having some objectionable gas or odors are there, then by aerating your water you have to remove these objectionable gases. Basically in water treatment plant, the first treatment method which is used, which is called as coagulation and flocculation. So this treatment is generally used for the removal of the dirt particle that is responsible for basically turbidity. So generally in the rainy season when highly turbid water is coming, at that time only this coagulation flocculation process is done. So basically at the plant we are adding certain chemicals like alum. Alum is widely used coagulant, and that will cause the tiny sticky particle or flock to form. Basically when we are adding alum to the water, then at that time it will form a positive charge of particle of Al plus plus, and generally in water that contains a turbid particle, they are generally negatively charged. So both the particles they will combine together, it will make a bigger size particle which is generally called as flock. So this flock attract the dirt particle and making them eventually heavy. So its size become large, and automatically under the force of gravity it will be settled down. So these two process, coagulation and flocculation. So coagulation is nothing but it is the addition of coagulant, and that is generally done at very high speed. So that's why it is also called as the fast mixing. And the flocculation, here the speed of stirrer that is adjusted at low speed, because we are giving time for all the coagulants to react and to form the flock. So generally coagulation is fast mixing and flocculation is slow mixing. After flocculation, big size particle flocks are formed, so that are to be settled down. So that process is called as sedimentation. So in the sedimentation tank, the flocks are settled down, and these heavy flocks which are settled down at the bottom and that are to be removed. So generally in the sedimentation tank, whatever that solid flocks are settled down, it is generally called as sludge, and that sludge is to be removed properly. After sedimentation, once we have removed the suspended impurities, next is filtration process. If certain uh, suspended impurities are still remaining, then we have to pass our water through the layers of gravel, sand, and perhaps it may require certain time charcoal also. And again we have to filter out our water to remove the remaining particles or remaining suspended solids. So the flow of treatment is generally coagulation, flocculation, sedimentation, and filtration. After sedimentation, most important treatment which comes up, that is called disinfection. So disinfection is nothing but it is the killing of microorganism, and for that certain chemicals are to be added. So widely used chemical in India is chlorine, due to its good disinfecting power as well as some residual effect, which is once you are giving treatment in water treatment plant, it has to be supplied to distribution system. So in the distribution system, if further recontamination take place, and if it goes on decade, and you may not find any chlorine proportion, but it has good power, that is called as the residual chlorine. It will keep it uh, safe against the further contamination. So generally it is also cheaply available, also good disinfecting power, also residual power is available. Due to that, in India, chlorine is widely used disinfectant. So this chlorine and other disinfecting chemicals, they will kill and any remaining pathogenic microorganism in our particular water. Because in the filtration also, there are two types of filtration that you will learn in detail in all the theoretical part: rapid sand filter and slow sand filter. Because certain amount of microorganisms are removed there also, so whatever remaining, that has to be removed in the disinfection process. Once disinfection is done, next, it is not the process, but it's just the storage unit. So here, whatever treated water is there, it is to be stored and supplied to distribution system. So this distribution system, it is just to distribute the purified water to the consumer by distribution system of pipes and conduits. So generally in India, the water distribution system is adopted in such a way that the whole city is divided into various zones, and in each zone overhead tank is provided, and before overhead tank, one underground storage tank or clear water reservoir is provided, in which chlorination is done to the treated water which is coming from your water treatment plant, and then after it is lifted off by pump, and then it is supplied through gravity to consumers. So at when it reaches to your house, whatever drinking water standards for different parameters are to be maintained. And generally one parameter which is very important, that is called as the residual chlorine. Minimum zero point 0.2 milligram per liter of residual chlorine has to be present when the water reach to your house. Then you can say that you are safe from the further contamination point of view. So this way you can draw a simple line flow diagram in your exam. You can show surface water source. Next is collection and conveyance structure, that is intake structure. Then screen for the removal of large floating impurities, aerators for the removal of odors and gases. Coagulant tanks, nothing but addition of chemicals like alum, that is through fast mixing, which is called as flash mixture. Then this is the unit which is here written clariflocculation. It is nothing but it is the combination of unit in which flocculation and sedimentation is done in same unit, which is generally called as clariflocculator. After clariflocculator, still further uh, impurities are there, then that is to be passed through filtration unit. So filter bed, so there are two types of filter: rapid sand filter, slow sand filter. Then after disinfection, and that is generally done with the help of chlorine or Cl2, and then after it is transferred to distribution system. So this way also you can show your water treatment plant layout. This is conventional one: raw water, coagulant, that is fast mixing, coagulation process, flocculation process, sedimentation process, filtration process, disinfection process, treated water storage, then distribution and coming to your house. So this figure shows the aerial view of typical water treatment plant. Here the unit that you can see, it is nothing but it is simple sedimentation tank. So here I will give a quick look to all the units that are generally included in water treatment plant. So this is nothing but intake well, that is collection system, intake well constructed along with this footbridge, over which you can see this conduits or conveyance pipeline which will carry water to water treatment plant. Generally pumping is done depending upon the location of your water treatment plant. Is it above your source or it is below your source? Depending upon that, pumping may be required or not required. This is nothing but this is bar screen. So this bar screen is generally used for the purpose of removal of large floating impurities such as plants or some woody materials are there, some fish is there. So depending upon this spacing of the bars, the different types of bar screens can be provided. Then these are cascade aerators. So basically in this aeration is to be provided to supply air. So here it is a cascade type of aerator. Number of steps are there. Water will be passing through these different steps, and at each step oxygen is supplied from the air, and due to that natural aeration, the impurities such as odors and some gases that will be removed. Here this is the whole process of coagulation flocculation. So coagulant are added in a definite proportion that you can use how much coagulant is to be added through your jar test that you have learned in your practical part. So rapid mixing is done, and generally it is done at the speed of 200 to 250 rpm. Here slow mixing is done. So generally rapid mixing is done for around 1 minute. Slow mixing is generally done for 15 to 20 minutes, and that is generally at the slow speed, that is 20 to 40 rpm. After this flocculation, bigger flocks are formed that are to be settled down. So here under the force of gravity that will be settled down. So this unit is clarifier or sedimentation tank or settling tank, different names are there. So these all impurities that are settled at the bottom, all are suspended settleable solids. This is called as sludge, that is to be removed properly, and then after it will go to filtration plant for the further removal of suspended matter. So here this is the figure of typical sand filters. So generally this water which is coming, it will be passed through first sand layer. So generally fine sand is provided at the top layer, then medium size range, then after gravel, and through the under drainage system it will be transferred to next unit. So this is the aerial view of a few filter beds, and there are two types of filtration generally used, that is slow sand filtration and rapid sand filtration, and that you will learn in detail as a unit. Next is disinfection process. So this is very important process. Chlorine gas generally which is stored in some units like this bigger cylinders that are to be supplied to water in the clear water reservoir directly. So by pressure regulating valve, pressure etc is regulated, and it has to be supplied, and this chlorinated water is generally stored in a clear water reservoir. So this is the figure of clear water reservoir. So after chlorination, so generally chlorination is done in this particular unit itself. So here this is the figure of clear water reservoir, and this clear water reservoir that will store clear water, and generally here inverted pipes are generally provided of this shape, so that from here the erosion, natural erosion would take place, and it is generally bent because some birds or some impurities should not enter in your water. That's why some bent is provided. After clear water reservoir in treatment plant, as I discussed, uh, this water is to be lifted up in overhead tank, and from this it will come through gravity, and through various pipelines it will reach to individual's house, and it will reach to your house. And whenever it reach to your house, it has to fulfill all the requirement of drinking water standard 10500/2012, and most important parameter is residual chlorine, that is zero point 0.2 milligram per liter is to be maintained. So this way the whole flow diagram you can prepare, and along with that you can write down all the functions in short. Now we will discuss about wastewater or sewage treatment plant. So basically whatever domestic wastewater coming out from the community, it is generally called as sewage, and this wastewater treatment is a process to remove all the contaminants from wastewater or sewage. And when this wastewater passing through sewerage network, it enters any wastewater treatment plant, generally it is called as influent. So whatever comes to your wastewater treatment plant is your influent, and when after complete treatment, it is generally called as the treated effluent. And once it is treated, this treated effluent can be returned to water cycle, means we are discharging it in nearby river or stream with minimum impact on environment. And if we are going for the further treatment from the conventional one, and that is we are applying advanced treatment, then it can be directly reused or recycled. So here before going to its complete diagram, we should know objectives of wastewater treatment. So objectives of any municipal or industrial wastewater treatment is removal of suspended and floating materials. So all the suspended matter and the floating matter is to be removed. Treatment of biodegradable organics, because if this biodegradable organic matter it is discharged to nearby river or stream, that will deplete your oxygen, and that will increase the BOD and COD. and also it will decrease your DO. That's why it affect the aquatic life. And minimum 4 milligram per liter, that is the requirement of DO, that cannot be maintained. So removal of this biodegradable organic matter is very important part of any treatment process, that is wastewater treatment process. Elimination of this pathogenic microorganism, because as you know it is harmful. Also to remove the toxicants if they are present. So that quality of discharged wastewater, which is after treatment, is improved to reach the permissible level to the water to be discharged into water bodies or for the agricultural land. So it has to fulfill certain requirement, and as per that standards you have to treat that wastewater. So generally this BOD level, it has to be brought down to 20 milligram per liter, and COD level, it has to be brought down to 100 milligram per liter as per our Indian standards. So basically treatment of wastewater, it aims at the removal of reduction of BOD, COD. Also it should not happen that it is responsible for eutrophication, means it should not enrich the level of nutrients in your receiving water body, otherwise it will result in eutrophication. Also it should not result in biomagnification of toxic substance, and that may affect your food chain. So all these are the objectives of wastewater treatment. So here you can see that more impurities are to be removed as compared to water treatment. Here the wastewater treatment plant, its layout, it is more complicated as compared to water treatment plant. So any wastewater treatment plant, that is conventional one, is generally having 4 different stages. So first stage is preliminary treatment. So in the preliminary treatment, our main aim is for the removal of debris, any suspended matter, grit, oil and grease removal. So these are all to be removed in the preliminary treatment method. Next is primary treatment. Here our main aim is to remove the settleable suspended solids. So all which can be settled down under the force of gravity, generally that are to be removed within the primary treatment. Next is secondary. Secondary treatment generally involves biological treatment to remove organic matter. So here in the secondary treatment, our major focus is the removal of biodegradable organic matter, and here the use of biological agencies or microorganism will come. Next is tertiary treatment. So in the tertiary treatment, it's the advanced treatment. If you want to reuse and recycle your wastewater, then only you have to go for tertiary treatment. So here all the steps involved in this particular wastewater treatment plant we will learn. That is preliminary treatment. So generally screen chamber and grit chamber, that are generally used for removal of all these debris and suspended solids, grit, oil, grease, etc. And water has to be passed through screens, grit chambers and skimming tank. So generally the skimming tank that are used for the removal of oil and grease, grit chamber for removal of grit, that is inorganic matter, and the screens for the large floating impurities. Next is primary treatment. In this is just simple sedimentation, which is called as the primary sedimentation. So just by simple settlement of your suspended solids, it can also remove 60% of suspended solids. Along with that, 30% COD, around 35% of DOD, 10% of uh, uh, P, and 20% of total nitrogen can also be removed. So generally by simple settlement, 50% of the suspended solid can be removed by gravity settling under the quiescent condition. If by simple settlement, if it cannot be removed, if it is industrial wastewater, then mechanical flocculation and coagulation, that we have discussed in a water treatment plant, that kind of treatment may also be adopted. Now in certain treatment plant, if it is highly acidic or alkaline wastewater, then you have to do it neutralize it, do its neutralization. Means in acidic water, wastewater, we have to add alkaline, in alkaline we have to add acid. Next is secondary treatment. So as I discussed, that our major aim is for the removal of organic matter in the dissolved or colloidal form, and it has to be generally removed by two process which are purely biological, aerobic and anaerobic. So generally this aerobic process, that is used for the sewage. So whatever is supernatant, that top layer, it is generally called as sewage. So for that generally different methods are used, like aerated lagoon, trickling filter, activated sludge unit, oxidation pond, etc. So in this semester you are going to learn in detail about all these units. Next is anaerobic process. So anaerobic process in the absence of oxygen, and generally whatever settle down under the force of gravity in the primary sedimentation tank or secondary sedimentation tank, which is generally provided after your erosion unit or the biological unit. Both are to be collected, which is called as sludge, and it has to be supplied to anaerobic digester. So in the secondary treatment, generally it may remove 80% of COD, 90% of BOD, 30% of P, 50% of nitrogen, and oil, grease, phenol, grit, scum, etc. can be removed. So last treatment is tertiary treatment. Basically, it's an advanced treatment. And if you want to reuse, recycle your wastewater, then it has to be further remove fine suspended solid, trace of other organics remaining, and nutrients and bacteria which are not removed in our conventional wastewater treatment plant. So this tertiary treatment for the recycling, generally different methods are used like coagulation, flocculation, sedimentation, disinfection. So generally these are the process which are using for water treatment. It has to be applied or adsorption by activated charcoal. So filtration bed of activated carbon that can be used, ion exchange process, ultrafiltration process, reverse osmosis process, electrodialysis process. So these are all advanced treatment method. If you want to reuse and recycle wastewater after conventional treatment, then you have to go for this tertiary treatment method. Here in this figure, a typical flow diagram of conventional wastewater treatment plant or sewage treatment plant is shown. So wastewater coming from any town, first it has to be supplied through this preliminary treatment method, that is bar screen, commuter, and grid chamber. So all this are already I have discussed. This is preliminary or the physical treatment. Next is primary treatment, that is primary sedimentation tank. So all the settleable suspended solids that will be settled down. After that it has to be transferred to secondary treatment, that is generally erosion tank. So here this is nothing but it is a activated sludge process, and after here all the organic matter will be removed. Then it will go to final sedimentation tank. So here final sedimentation tank, after that you can discharge this wastewater to nearby stream or river. And if you want to reuse this wastewater, so we are just now talking about only sewage or supernatant part, and depending upon your requirement you can give your tertiary or advanced treatment. So in the final sedimentation tank and primary sedimentation tank, the sludge is formed. So both these sludges are to be collected together, and then it has to be applied treatment that is generally called as anaerobic digestion. And certain amount of sludge it has to be recycled in erosion tank, because in erosion tank in the activated sludge process the active mass of microorganism is very essential. So this return sludge in the erosion tank, inlet of the erosion tank, it will maintain that active mass of microorganism which is required for the degradation of organic matter. So these two sludges, when they are brought back to this anaerobic digestion for the further treatment, generally the gases are formed, that is anaerobic digestion. The end product is generally methane and carbon dioxide. So methane can be used as a fuel or electricity generation. After this, for further removal of moisture, the sludge dewatering is done, and generally in India it is done with the help of sludge drying bed. And last, this sludge after drying, it has to be supplied as a manure, and either it can be useful for the disposal, or depending upon the quality you can use it as manure. So this is the typical aerial view of any wastewater treatment plant consisting of all the units. So now quickly we will see all these units. So here this is the figure of bar screen. So this bar screen, they are used for the large removal of large floating materials and pour solid from that, and generally they are keeping these bars are generally inclined at 30 to 60-degree angle, and they are provided with certain opening wires consisting of parallel bars, wires, or grating. So generally three types of screens are there: fine screen, medium screen, and coarse screen, according to its size, and it may be manually or mechanically cleaned. So you are going to learn further in detail in all the units in your theoretical part. Next is grid chamber. So here the grid chamber is nothing like simple sedimentation tank. So this grease, if it is present, it will cause wear and tear on the pump, so it is very necessary to remove. So generally it is a long narrow tank that are designed to slow down the flow. It's velocity is very important. So here the velocity is maintained in such a way that the all the grit particles that will be settled down and that will be collected at the bottom, and this fat, oil and grease that will float at the top, and that can be going for further for the treatment. So next treatment is settling or the sedimentation tank. So just by simple settlement, so here this sludge scraper mechanism is provided at the bottom. So all the sludge which is settled at the bottom, it has to be collected, and this sludge will go to further treatment, which is called as the sludge treatment in the anaerobic digester. So this is the aerial view of sedimentation tank. These are after a sedimentation tank, primary sedimentation. Next is your activated sludge process or aeration tank. It's a biological treatment process. So here active mass of microorganisms that are kept, and here you can see this is aerators. So these aerators, they are constantly supplying air and oxygen to the microorganisms, and these microorganisms, they will use organic matter as their food and degrade them, and they are responsible for degradation of organic matter. So it's purely biological process. After that, whatever sludge that is collected in primary sedimentation tank as well as secondary sedimentation tank, here it is to be supplied to anaerobic digester. So anaerobic digester is nothing but it's a sequence of process by which microorganism break down the biodegradable organic material in the absence of oxygen. So generally this one of the end product is biogas, and that is basically methane along with carbon dioxide. So it is used for the electricity, and it can be used as a natural gas, and can be useful for the transportation fuel. So here basically when the sludge is coming, this active sludge is there, then stabilized sludge for zone is formed about. During this process the clear layers are formed, and that may take a different time period depending upon the temperature, mixing, etc. So here supernatant, this is scum layer, and this top, at the top the gas is collected. So you are going to learn in detail about all these processes in your further classes. And the last one, after a digested sludge, this digested sludge is to be applied for further removal of moisture, and this is generally called as the sludge dewatering. So most widely used method in India is sludge drying bed. So they are just simple bed consisting of sand material and gravel. Just you have to apply your digested sludge over that, and just you have to dry for 14 to 15 days all the moisture that will be passing through all this, and this pipes and drains that are collecting this leachate, which is, this is generally called as leachate, and that is further applied to uh, process right from the primary sedimentation tank. And this sludge, after drying after 14 to 15 days, it has to be scrapped, and that can be used and as manure, and it can be useful for earning money also. So both the product, that is biogas which is coming from the anaerobic digester and this manure coming from the sludge drying bed, both can give in terms of money. So I have discussed all the uh, treatment part that is to be included in water as well as wastewater, and I am sure that whatever portion that I have explained you, that is very useful to you, and it will give benefit in your examination also. So thank you very much.